This is file WB6.2 and it's associated with the example of the courier problem, the allocation problem discussed in the course material. It is key to organize the data in a way that is easy to read and easy to play with. So again, the data here is all shown shaded in green. It's obtained from the example. We know that the maximum total time for each run is 240 minutes. The maximum route time is 120 minutes. Here we have the commercial speeds of the drivers, and we also have the variable compensation part. To solve this type of problem, we introduce the concept of binary numbers. In this yellow portion of this matrix, the numbers can only be zeros or ones. 0 means that the route is not assigned to this courier. 1 means that the route is assigned to the courier. In this column, we have a check number. And the idea is that we have to assign all the routes to someone. So all the numbers in this column should be ones. And in here, we have the calculation of time. The maximum time for each courier is 120 minutes. The maximum time for all the routes combined by courier cannot exceed 240 minutes. And here we have the variable compensation for the different couriers. I'm going to delete these numbers here to start the optimization process. So let's start the solver. The first question is the objective. What we want to do again is to minimize cost. So the total cost is here. So we want to minimize the variable payout. And then we select the minimum. What we want to change is the entire set of numbers in yellow. In other words, the allocation of routes to couriers. So those are the changes we want to make. And let's then put the constraints. First constraint I'm going to put in is the constraint that determines that these numbers are binary numbers. They can only be zeros or ones. We use this pull down menu and select binary from it. Immediately that is written on this side. Let's now put other constraints. We know that the maximum time each particular route can take is 120 minutes. So we say that this is less or equal than 120 minutes, which is here. Then the other constraint is that the total time per courier cannot exceed 240 minutes. So that is entered by putting the 240 minutes here. The other constraint we have to add is that every route should be assigned. So we can add that here by saying each route must be equals to 1. We can enter the 1 here. Now we have all the constraints in there. We're going to employ the simplex linear programming method and we hit solve. This could take a little longer than other problems and very much depends on the speed of the computer processor. After some processing time, this window comes out. Solver found a solution. All constraints and optimality conditions are satisfied. When we see the outcome, we can see that the variable payout is $2,715 and that this is the way the routes are assigned. Route A is assigned to John. Route B is assigned to David. Route C is assigned to Carlos. D also to Carlos. E to Chris, and so on. As you see, some drivers have 2 routes. Some drivers have only 1 route, such as Dana. As the fastest driver, she has the highest compensation. all routes have been assigned, as we see here. And we see that no driver exceeds 120 minutes individually. David reaches that maximum, so does Fred and Carlos as well. None of the drivers reaches the 240-minute maximum for all the routes included. So this is an application of the solver to optimize allocation of resources.